Hello everybody. So what we're going to be doing today is we're going to be looking at tangent and cotangent graphs. But before we do that, I had a couple of emails saying that the graphing of sines and cosines was pretty tricky, and we're hoping that I would give a little bit more help, specifically with graphing cosines. So I'm going to do a couple problems for cosines before I do today's lecture. Good news, by the way, the graphing of tangents and cotangent is going to be much easier, I think, than graphing for sines and cosines. So let's go ahead and look at some cosine examples. All right, so we're not doing today's topic yet, we're doing review. Cosines, graphs. Okay, so I'm just going to get a couple questions from the homework and do them and hope that that is in some way helpful. So here's an example from the homework. It says graph the following. Y equals -3 cosine x over 2 plus pi over 8 minus 1. Okay, and something I'm going to do here is I'm going to do this in a slightly different way than I said in the previous lecture. Just it's a little bit more writing, but hopefully it'll maybe be a little easier to understand. So first thing I'm going to do here is I'm going to write this as 1/2 x plus pi over 8 in here. So -3 cosine 1/2 x instead of x over 2. That just makes it easier. Now we're comparing this to, if you remember the previous lecture, we're comparing this to this. Y equals a cosine bx minus c plus d. Okay, so by comparing the numbers here to the numbers here, you should be able to figure them out. Okay, now what you're going to do first on any of these graphing problems is there's a lot of preliminary things you can calculate. So you're going to calculate lots of stuff. What are you going to calculate? Well, you're going to calculate the amplitude for sure. So the amplitude is going to be the absolute value of the A. So it's the absolute value of -3, so it's 3. Another thing you're going to need is you're going to need the period. The period is going to be 2 pi over the absolute value of B. So it's 2 pi over the absolute value of 1/2, which when you divide by a fraction, remember that that is the same thing as multiplying by the reciprocal. So dividing by 1/2 is actually multiplying by 2. So 2 pi over 1/2 is 4 pi, like that. So amplitude period, we're going to need the phase shift and the midline. So let's do the phase shift. And so the phase shift is C over B, no absolute values. So you have to be careful here though. So notice that there's a minus in the form that of our general form of the cosine. Okay, and we have a plus. That means that basically for the C, you need to reverse the sign that you see there. So I see a plus pi over 8. A plus pi over 8 means that C is actually negative pi over 8. All right, and then the B is 1/2 again. So just like before, dividing by 1/2 is multiplying by 2 over 1. So you work that out, you get -2 pi over 8 or negative pi over 4. All right, so I've got my phase shift, I've got my period, I've got my amplitude. What else? We need the midline. So the midline is y equals just d. So what is it here? It's just y equals -1. Okay. Now, what we did before was I said you should calculate a quarter period, and then I just said that, oh, that's helpful to have. And it is helpful to have. But I'm going to say that what we should do is we should do more than that. We should calculate quarter period, because we're going to need that. So let's find that. So that is, what it says, 1/4 times the period is 1/4 times 4 pi, which is just pi. Right, so quarter period is pi. Now, if you're having trouble graphing these, here's a way you can do it that's more like, how should I say it? Like less thinking, but more like writing the same thing every time, which a lot of people think is helpful. So what you might want to do is make a table, and we didn't do this last time, but make a table of values. And we're going to plot the table of values, and that's going to hopefully be easier for us. So you make a table of x values and your y values, okay? And what you're going to do is you put your x values here, you put your y values here. Now your x values, the first x value you're going to put here is going to be the phase shift, okay? So I'm going to write this in general. You're going to put the phase shift as your first x value, okay? Now from there on, what you're going to do is you're going to be adding 1/4 period. That's why I calculated a quarter period here. What you want to do is so I'm just going to write PS for phase shift, so like PS equals phase shift. So phase shift, which I didn't even write. So like PS plus quarter period. Does that make sense? The next one's going to be phase shift plus a half period. Or if you want to think of it in quarters, 2/4 periods. And then phase shift plus 3/4 periods. And then PS plus 4/4 periods. Okay? So the P there is period. All right. Now, what you're going to do for the y values is this. So in the normal cosine graph, so this is for a cosine, it'll be different for a sine. Normally, a cosine starts out at the top, and then it comes down to the middle, and then it goes to the bottom, and it comes back up to the middle, and then it goes back to the top. That's what one period of the cosine looks like, okay? But what you're going to get, though, is like, what is this value and what is this value? And so the first y value is actually going to be the A plus the midline. Okay, so whatever the A and the D are. And there's no absolute value there. I'm not talking about the amplitude. It's A plus the D, the actual numbers. Okay, then so that's going to be the equivalent of this point right here, this first point. Now the next point is going to be the equivalent of this one. That means it's just going to be at the midline. Then you want the equivalent of the third point. That's going to be the D minus A. And in fact, maybe I'll come back here and I'll rewrite this as D plus A. So you have D plus A and D minus A. The next one is going to be D again, because you're back at the middle. And your last one is going to be D plus A. All right? Now, I understand that there's like a lot of letters there in that table, but I think you'll see that it's actually pretty helpful for graphing, because if you have that table written out for you, or you make it every time, then you don't have to think very hard about what to do. So like, let's try it here. So this is only for a cosine. I'll write it for a sine afterwards. Okay, so let's try this. So x, the first x value should be the phase shift. What's the phase shift? There it is. Pi over 4. Right? Pi over 4. Okay? Now let's just do all the x values. So the next x value is negative pi over 4 plus a quarter period. So what's a quarter period? That's why I calculated it, right? Quarter period is pi. All right? Now you can add those together and get a number. What is it? It's move that over a little bit, sorry. It's going to be 3/4 pi, it looks like, right? Pi minus a quarter pi, 3/4 pi. Next one is, where are we? We're here. So the phase shift, why did I just write a 2? Phase shift, pi over 4, plus 2 over 4 periods. You know, you could write that however you want, right? You could write that at, like, I don't know why I wrote it the way I did. I'm even going to erase this real quick. Maybe a nicer way to have written that would have been PS plus 2 quarter period. And same thing for this one. Like maybe we should have done 3 quarter period. And then the last one would be 4 quarter period. So anyway, back over here. So we're still doing this one. So 2 times a quarter period. So that's 2 pi minus pi over 4. So I mean, you still got to work out the fractions, but 7 pi over 4. The next one is PS, which is negative pi over 4, plus 3 times quarter period. So you have 3 pi minus pi over 4. Well, that's going to be 12 pi minus 1 pi, 11 pi over 4. Now, by the way, there is a pattern here that you can notice eventually. Like there's a 3 and then a 7 and then an 11. So like without, doing too much work, what's the next one going to be? 3, 7, 11. We're adding 4 every time. So it's going to be 15 pi over 4. All right. So anyway, we got those x values. And, you still have to add them carefully like I did, but, you just write them all down. Now, for your y values, those are going to be easier now because we're just reading the values from the table. So you have d plus a. So where are the d, where's the a? So let's see. Well, what's the d? The d is negative 1, right? So d equals negative 1, and the a was, I believe, minus 3. Yeah, right? Yeah. So when we do d plus a, it's going to be negative 1 plus negative 3, or just negative 4. And then we have d, so just negative 1. And then we got d minus a, so that's negative 1 minus 3. So that's negative 1 plus 3, which is 2. Then you've got d again, so that's negative 1. And then you've got d plus a, which is the same as the starting value, so negative 4 again. So overall, I've got these x values and these y values, okay? And I haven't thought too hard. I just had to know what values were going to be in my table to get those. So with those in mind, let's see if we can plot this now. Okay, so what do we need? So we have 3 y values we care about: negative 1, positive 2, and negative 4. So actually, let me just erase this line and put it like on an actual line. I still didn't do it. Okay, so let's see. And the y values, they go up to, the x values go from negative pi over 4 to like close to 4 pi. So let's just do like every box is a quarter pi. So let's do negative pi over 4 is right there. And then 1, 2, 3, 4. So this is pi. 1, 2, 3, 4. 2 pi. 1, 2, 3, 4. 3 pi. 1, 2, 3, 4. 4 pi. Okay. And then for my y values, I need negative 4 up to positive 2 on here. So let's go 1, 2, 3, 4, negative 4, 1, 2. It's up to 2. We're there. Okay. So let's put a couple things on here. Let's put our midline. Where's the midline? Negative 1. So let's put y equals negative 1 on here. So here's our midline. And now we should be able to plot this curve pretty well. So x's and y's, right? So here's our first point. Negative pi over 4, negative 4. So negative pi over 4, negative 4 is right here. Next one. The next one is 3 pi over 4, negative 1. So the way I did it 4 boxes to be a pi. That way every box is a quarter pi. So I'm supposed to be like, this is the x value that I'm at for 3/4 pi. And I'm at 3/4 negative 1. So that's actually right here. Then the next one is 7 pi over 4 comma 2. So that's just one box before 2 pi. So that's up here. Next one is 11 pi over 4 comma negative 1. So that's just before 3 pi. So that's down here. And then the last one you can check, but it'll be one box before 4 pi and down at negative 4. So right here. All right. And so what the graph looks like is this. So like I didn't have to think about whether this was right side up or upside down or anything like that, because that's taken care of by using like the appropriate a value there. If a is negative, it's upside down. All right. Now if you wanted to keep going, what you would do is you would just continue this pattern. So like 1, 2, 3, 4, like this would be 5 pi, and then 1, 2, 3, 4. That'd be 6 pi, 1, 2, 3, 4. That'd be 7 pi. And the points that we're doing are not actually there. They're one box before that. So like there should be, we're at the bottom. The next one should be in the middle. The next one should be up at the top. Next one should be 1, 2, 3, 4 at the middle again, like that. And then the next one, which I didn't leave room for, would have been, oh, I put that in the wrong place, sorry. There. Right, so then if you continue the graph, it does this, right, and then keeps going that way. Same thing this way, we didn't plot it, but it goes up there. All right, and so maybe that's an easier way to plot this for you, is to use a table of values like this. Okay, yeah, maybe. It's just a recommendation. Okay, now if you wanted to do this for a sine, you could. I don't think I can justify going through all that again for like a full-on sine. Maybe I can. Let's try this. I'm not going to make it too complicated though. I'm going to go 2. I need to actually give it a name. That's not that. Let's say plot y equals, let's just say 2 sine x minus pi over 6. All right, that's going to be good enough. Okay, no, let's do like plus 1. Okay, it got complicated, sorry. So what you would need to do is all of that same stuff. So you need the amplitude. Actually, you don't really need the amplitude, but for other things you do. Amplitude is absolute value A. It's 2. Period. It is 2 pi over the absolute value of B. So 2 pi over, well, there's no coefficient there, so it's over 1. So 2 pi. We need the phase shift. So that's C over B. So C is pi over 6. Remember, you change the sign there. So if it's a negative, the sign's the C is positive pi over 6 when you see a negative pi over 6. Over B, B is 1 again. So just pi over 6. Right? Now we do need, or you could have a quarter period. It's good to have. And so that's a quarter of the 2 pi. Quarter of 2 pi is pi over 2. All right. Oh, we need the midline. Midline. Y equals D, which is y equals 1. Okay, so we're good. So there we go. So we did all that same stuff again. But again, what I'm going to suggest is that we're just going to use a table of values. So x and y, and this is going to be for a sine. So your x values, you're going to get them exactly the same way. So they're the same ones here. So like PS for phase shift. So PS for phase shift. Then the next one is PS plus 1/4 period. The next one is PS plus 2 times quarter period. PS plus 3 times a quarter period. And PS plus 4 times quarter period. Your y values this time are different because remember what a sine looks like, right? A sine starts in the middle and then goes up to the top and then down, back down to the middle and then down to the bottom and then back up, right? So it's the same kind of shape overall, but it starts at the midline. So when you write down what the y values are, the first y value is actually the midline, which is D. The second one is at the top, which is D plus A. The next one's back at the midline, right? Third one. The fourth one is D minus A. And then the last one, back at the midline. So if you look at this, right, it's the same kind of pattern, but this one starts at D, whereas this one starts at D plus A. Other than that, it's the same thing. Okay? So for us, what's our table look like? Our table is going to look like this for this problem. Oops. Don't care. So we're starting at the phase shift. What's the phase shift? Pi over 6. Okay. Next one is pi over 6 plus a quarter period. Quarter period was pi over 2. Right. Next one, I'm going to write in what that is in a minute. Next one is the phase shift plus 2 times quarter period. Next one is pi over 6 plus 3 times quarter period. And the last one is pi over 6 plus 4 times quarter period. Right? Y values, let's put those in. Starts at D. D is the midline. So that's 1. Next one is D plus A. That's 1 plus A. What's A? 2. Right? So 3. The next one is back at D. So that's at 1. Next one is D minus A. So that's 1 minus 2. That's negative 1. All right. Last one. D, which is 1. Okay. Now you need to add these together. If you have a calculator that can do that, that's great. It's good to have a calculator that can add fractions. If you don't, you could use Wolfram Alpha to help. So like pi over 6 plus pi over 2, you come here, you go Wolfram Alpha. pi over 6 plus pi over 2. No, plus pi over 2. Hit enter. It'll be 2/3 pi. There it is, right? 2/3 pi. A lot of calculators do this type of problem for you, but not everyone. So this is 2 pi over 3. All right. The next one's going to be 7 pi over 6. Just going to do these in my head here to the extent that I can. Pi over 6 plus 3 pi over 2. I don't know that. Five pi over 3. I guess I could have known that. Last one is going to be... Oh, this is wrong. I made a mistake. Hold on. Oh, no, I didn't. I made a mistake here. I wrote a 4, but that should have been pi over 2. Right, 2 pi plus pi over 6. 13 pi over 6. So pi. Okay. Can't really read that. Okay, close enough. So, once you have those, then we want to be able to plot this. So let's just make a set of axes here. Make it long. The reason I'm making it long is I see this goes up to 13 pi over 6. That'd be nice if that was just 13, right? So I'd like to go like pi over 6, 2 pi over 6, 3 pi over 6, like that. So like 6 boxes to be pi, basically. So 1, 2, 3, 4, 5, 6. This is pi. 1, 2, 3, 4, 5, 6. This is 2 pi. 1, 2, 3, 4, 5, 6. This is 3 pi. 1, 2, 3, 4, 5, 6. This is 4 pi. Okay. Now, on the y-axis, we just have like what? -1, 1, 3. Okay. So let's put like -1 there. That makes this +1. This makes this 2. This makes this 3. Okay. Good enough. Let's go and plot this now. So, what do we got? We got pi over 6 comma 1. Put that in the right place. Pi over 6 comma 1. There it is. And by the way, we can draw on our midline. Our midline was y equals 1. It's good to have that just marked so we know where the middle is. Okay. All right, next one. 2 pi over 3, 3. So 2 pi over 3 is 4 pi over 6. So that's here. And it's supposed to be up at 3. So that's up here. The next one is 7 pi over 6 comma 1. 7 pi over 6 is 1 box past pi. So that's here. Then we've got 5 pi over 3 -1. 5 pi over 3 is 10 pi over 6. So that's 10 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here. 10 over 6 pi. That's supposed to be at -1. That's done here. And then the last one is 13 pi over 6. Which must be, hold on, 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, right there. All right. So every box is pi over 6. So that's those are the points that I have. So I plot these on here. I can connect the dots, and that's my graph. Okay. Now one thing you'll notice is that like if you count the number of squares I go over, every point is like 3 squares over from the other one. So like I can go like this here, 1, 2, 3, and then that one should be up at the top. And then I go 1, 2, 3, and that should be back at the middle. And then 1, 2, 3, that should be down at the bottom. 1, 2, 3, and that should be back at the middle. And then connect the dots with not a very good looking graph, but it's going to be good enough. Okay, so maybe this is a nicer way to do it. Okay, maybe it's a nicer way, making that table. Okay, so I still don't even want to stop there. There's, I think, making the graph is not that bad, but then, hold on a second. Making the graph might be okay, but then writing the equation of a graph could be hard. So I want to do one writing the equation of the graph with a cosine, and then we'll move on to tangents and cotangents. So I'm just trying to cheat here and find a good question for you guys. Yeah, here's a good one. It's a cosine. Okay, I'm not going to draw this in too much detail here. You're going to have to rely. No, why would you do that? Come on. So you're going to have to rely on me telling you that this is a cosine here. So they give us a couple of points here. They tell us that this point is pi over 2, comma, negative 1.5. They tell me this point is 9 pi over 2, comma, negative 1.5, same y value. And they don't say it, but they show that this point is at a y value of, I don't know what the x value is, I don't care, but they show that the y value there is negative 0.5. Okay? And what they want is the equation, and they give me this. Y equals empty box cosine empty box plus empty box. And I got to type in all that stuff, right? And so you want to be, there's kind of like a set way you go about this. Okay, so it's all related to what you do for graphing it, but backwards. So let's see. So for example, the amplitude, so the absolute value of A we know is the amplitude. However, another definition for the amplitude is that it's 1/2 the maximum minus the minimum values on your graph, and those are y values. So in this case, it's 1/2 the maximum. What's the maximum y value? It's up here, right? It's that negative 0.5. And then minus the minimum y value. What's the minimum y value? Well, it's negative 1.5. So you have 1/2 negative 0.5 minus 1.5. That's negative 0.5 plus 1.5. So that's a 1. So it's 1/2 times 1, and you get a 1/2. Okay? So what we know is that absolute value of A is 1/2. Now that means that A is either 1/2 or it's minus 1/2, and we don't know yet. I actually do know, but I won't explain it yet. Okay, so that's the first thing. You find the A, or almost find the A. Now the next thing you can do is you can find the B, because we know that the period is 2 pi over the absolute value of B. Now what we do here is you rearrange this so that B is 2 pi over the period. And another thing you do is that you can always write these so that the b is positive. So even though it's an absolute value of b, I'm just going to erase those absolute values there, okay? And just, we're going to have a positive b because that's what I want to have, okay? And that's okay, you can do that. So b is 2 pi over the period. So you have to know what the period is. So b is 2 pi over the period. What's the period though? On a graph, the period is how far you go on the x-axis before the graph repeats. So this is one period. From here to here is one period. So one period is going to be 9 pi over 2 minus pi over 2. That, because we want the distance on the x-axis there. So that's 2 pi over, that's going to be 8 pi over 2. So what is that going to be? That's going to be 2 pi times 2 over 8 pi, or 4 pi over 8 pi, or, I'm out of room, 4 pi over 8 pi is going to be just 1/2, isn't it? Is that 1/2? I think that's just 1/2, no pi involved. Can that be true? Hold on. No, that can't be right. Hold on. Oh no, because we weren't calculating the period, we were calculating the b. Okay, that's not the period. That's b. All right, so we have the period. No, we had the period, we have the b now, sorry. It's okay, so we have the a, we have the b, almost have the a. The next thing is we need the phase shift. So the phase shift, we know, is c over b. Now, the phase shift on the graph is how far over the graph is moved. So to the right. So this right here, this distance is the phase shift. So what's the phase shift here? Well, if that point is at pi over 2 comma 1.5, then the phase shift is pi over 2, right? Pi over 2. That's that distance. That's your phase shift. So you have pi over 2 is equal to c over b. Now it's c over b. We don't know the c, but we do know the b. We just calculated it. So we have this relationship right here. So pi over 2 equals c over 1/2. Well, that tells you that if you multiply this up to the other side, you've got 1/2 times pi over 2 is equal to c, or c is equal to pi over 4. So now you got the c. So you got the a, the b, the c, and you need the d. So for the d, just remember that the midline is y equals d is midline. And that should be easy to get from the graph. So the midline is just, I mean, there's a couple ways to do it. Well, I mean, I'll do it this way. Basically, I don't know. It's not as easy to see there because they didn't mark it, but I'll just write it this way. So basically the d is just going to be, it's almost the same as the amplitude, except it's 1/2 like the max plus the minimum. What's the difference? The sign right here. Because what we're doing is we're just averaging, right? If you want the middle, if you just average the top point and the bottom point, you get the average. Average is in the middle. So that's what we're doing. We're just averaging the maximum and the minimum. So average of the maximum, which is negative 0.5, plus the minimum, which is negative 1.5. So it's 1/2 times negative 2, so it's at negative 1. And so that's what d is. All right? So at this point, here's what we have. We have, I'm going to summarize. A equals, what was it, 1 or negative 1? No, 1/2 or negative 1/2. 1/2 or negative 1/2. And that's an or. The b we calculated was, that was 1/2. the c we calculated was pi over 4, and the d we just calculated was -1. So what you got is y equals a cosine bx minus c plus d. We need to fill them all in. The only question we have now is we need to figure out what the sign is on the a, plus or minus. And the way you do that is you just ask yourself if it's upside down or right side up. So you use this value if the graph was right side up, and you use the negative value if it was upside down. Now, what do I mean right side up and upside down? That's compared to the original sine or cosine graph is what you want to do there. So like on a sine normally starts at 0, 0 and goes up, right? That would be right side up. And a cosine normally starts up at the top and goes like that, right? This is what right side up looks like for a sine and a cosine. Now what upside down looks like are upside down. So like for a cosine, for a cosine, it'll start at the bottom and then go up. If it's a sine, it'll start at the middle and then go down, right? So can you see the difference like compare this one right here and this one right here. So upside down starts at the bottom and goes up for a cosine. So you need to know if you're a cosine or a sine, and then you can do these. All right, so let's look at ours. So look at your graph. Well, it's hard to see, but let me erase some of this to see. So this was actually like a cosine graph, right? So you see that it's a cosine graph and it's starting down here and going up like that. So it's starting at the bottom, right? So it starts at bottom, so it's upside down. So that tells me that this is the one that I want. -1/2, because it's upside down. So you have -1/2 cosine bx, b is 1/2, minus c, so that's minus pi over 4, plus d, d is -1, so just -1. And that's your graph right there. I'm going to type this into the computer just to make sure there are no surprises, but that should be fine. 0.5 x minus pi over 4. Oh, I have to actually type in a pi from the thing. I hate it when they do that. Pi. And then -1. Submit. Yeah, I did it. All right. So maybe that's helpful for graphing. What did I just do? Okay. Maybe that's helpful for graphing sine and cosine better than the previous lecture. Okay, so those are more foolproof methods. So we're already 43 minutes in and we haven't even started what we're supposed to be doing. So actually what I'm going to do is I'm going to stop this lecture here, and I'm even going to rename this here. So we're not going to call it lecture 11. I'm going to call it 10.5. Erase. 10.5. And this is not tangent and cosine, or tangent and cotangent anymore. Well, then I can move this. Sorry. So what is this? More sine and cosine graphs. All right. I'm going to stop this, and then we're going to start the tangent and cotangent, which I do promise you is easier than this.